For a second, let's forget about the kings, the conquests, all the usual stuff you hear about in history class. What if the whole story of humanity wasn't random at all? What if it was following a script? A script written not by people, but by chemistry, dictated by the metals right under our feet. Today we're going to climb the staircase of fire that literally forged our world. All right, let's get into it.
Okay, so right off the bat, we run into this massive historical head-scratcher. Iron is literally everywhere. It's one of the most common elements on this planet. But the ingredients for bronze, copper, and especially tin are pretty rare. So why on earth did our ancestors spend thousands of years in a Bronze Age using these hard-to-find materials before they ever got around to abundant iron? I mean, it feels completely backwards, right? But the answer? Well, the answer unlocks everything.
To figure this out, we have to go way back to the very beginning. Every big journey starts with a single step, and for humanity's journey with metal, that first step, that first, lowest rung on our staircase of fire, was copper. It was the very first metal we ever really got the hang of, and as it turns out, it was the only logical place for us to start.
Now, what's really fascinating here is how this maps out our technological childhood. An archaeologist named Colin Renfrew showed that this wasn't about some sudden eureka moment. Nope, this was slow, careful learning. You start simple, you find a shiny rock of pure copper, and you hit it with another rock. That's cold hammering. But you figure out pretty fast that just hitting it makes it brittle and weak. So you learn that if you heat it up a bit, it gets strong again. That's annealing. See? Each step is just solving the last problem, learning the lesson, and building the foundation for the next big leap.
And here we go. This is the first great filter of metallurgy, 700 degrees Celsius. This number is so important because that's the temperature you need to smelt copper, to basically rip the pure metal out of the rock it's trapped in. And the crazy part? This wasn't some brand new technology. It was a temperature our ancestors had already mastered in their pottery kilns. So get this, the first giant leap into the metal age was made possible by the humble potter's oven. But just getting the metal out of the rock wasn't enough. If you really want to make cool stuff, you have to be able to melt it. And that meant climbing to a whole new level of what we call pyrotechnology, fire tech, all the way up to 1,083 degrees Celsius. That's the magic number where solid copper becomes this glowing liquid river that you can pour into molds. It meant we needed way better furnaces, a lot more fuel, and a whole new level of skill.
All right, let's move on because this is where things get really, really interesting. Mastering copper was an incredible feat of engineering for sure, but the next step, it wasn't about engineering at all. It was a feat of pure imagination. It wasn't about finding something new in the ground, it was about inventing something new. And that revolutionary idea is what kicked off the entire Bronze Age.
So, what even is bronze? Well, you can't just go out and dig up a chunk of it. It's a recipe. It's an alloy. You take your copper and you mix in just the right amount of something else, usually about 12% tin. And what you get is this amazing new substance that's so much more than the sum of its parts. It's a brand new material, way harder and more durable than anything that had come before. An absolute game changer.
And this slide just lays it out perfectly, why that invention was such a big deal. Pure copper, it's pretty soft. A copper sword is going to get dull really fast. And when you try to cast it, you can get these tiny little gas bubbles trapped inside that make the whole thing weak. But tin bronze? Oh man, its edge was brutally sharp, and it stayed that way. It was stronger, it was tougher, and it cast into a near-perfect solid. This wasn't just a slightly better tool. This was the foundation for a massive technological and military advantage for any civilization that mastered it around 3000 BC.
Which brings us all the way back to our big mystery. If bronze was this amazing man-made material from rare ingredients, why didn't our ancestors just skip all that and go straight for the cheap, abundant iron that was lying all over the place? Well, we're finally at the answer. And it has nothing to do with the ore and everything to do with the ferocity of the fire.
1,200 degrees Celsius. Remember that number? That is the absolute bare minimum temperature you need just to begin the process of smelting iron. It's a heat so far beyond what Bronze Age furnaces could do, it might as well have been the surface of the sun. It required a complete reinvention of the furnace, new things like clay linings and powerful bellows, stuff that was pioneered by groups like the Hittites around 1500 BCE, just to get the fire hot enough.
And right here, laid out on this chart, is the final answer to our puzzle. Look, iron is harder. Its ore is everywhere. It should have been first, but just look at those temperatures. To smelt iron, you need 1,200 degrees. And to actually melt it, to pour it like bronze, you need over 1,500 degrees. Bronze could be totally worked with at around 950. So the simple truth is, for thousands of years, iron was locked away from us. We could see the ore, we just couldn't build a fire hot enough to unlock its secrets. But once humanity finally broke that 1200-degree barrier, the world changed forever. Mastering iron wasn't just the next step on the ladder, it was like hitting a turbo boost button. That slow, step-by-step climb up the staircase of fire suddenly became this explosive, exponential rocket ride to the top.
Just look at the pace on this timeline. For thousands and thousands of years, progress was slow. Then, in the 14th century, someone in Europe thinks to hook up a water wheel to their furnace bellows, and boom, they can finally melt iron at scale. And from there, the dominoes just fall faster and faster. The puddling process, then the Bessemer process, which gives us cheap, mass-produced steel, then the electric arc furnace. Thousands of years of slow progress got compressed into just a few centuries of insane innovation.
And the ultimate prize for mastering the fire of iron was this: steel. And just like bronze, it's an alloy. It's a precise recipe of iron mixed with just a tiny bit of carbon. And this material, steel, is, and this is no exaggeration, what built our modern world. The skyscrapers, the bridges, the cars, the railways, the entire skeleton of civilization is forged from steel.
So when you pull all the way back and look at the whole story, the path of human history suddenly snaps into focus. It doesn't look random anymore at all. It was a journey up a ladder whose rungs were set permanently by the fundamental laws of physics and chemistry. The melting points of the elements on our planet determine the unchangeable sequence of our own technological evolution.
And to really let that sink in, let's just play a little what-if game. Imagine a parallel universe. Everything is exactly the same, but we tweak just one little law of physics. What if iron could be smelted at 800 degrees Celsius? You know, just a little bit hotter than copper. What would human history look like then?
The consequences are just staggering to think about. There'd be no Copper Age. There'd be no Bronze Age. Why would anyone bother with rare, soft copper if abundant, super strong iron was just as easy to make? Humanity would have leaped directly from stone tools to iron tools. The entire timeline of empires, of warfare, of technology, it would be completely, totally unrecognizable. Our history, as it turns out, was literally forged by fire.
And that brings us to this really powerful final thought from Rochelle Forrester, whose work helped inform this explainer. The idea that our social and cultural history, it had to follow a particular course, one that was determined by the simple properties of the materials in our environment. It's just a profound reminder that for all our creativity and ambition, we are and we have always been shaped by the fundamental physics of the world we live in.